All right, so again, they get you to they're trying to distract you with basically the additional side of this triangle. Okay, we know what lines we have to look at. We know that we have that parallel line and that parallel line. We want to focus on those and use those. So now it's just a matter of picking a transversal. There's two transversals up there. Hopefully you realize that this transversal here is kind of a cruddy transversal to choose, because when I picked that and made them move the picture away, are there any values for any of these 8 angles that we create, and really only 4 angles that we create, that we know from the picture? No. So that transversal is kind of a bad choice. Okay? So then if you get a bad choice, go with the other one. Let's look at that transversal. Okay? And now the angles that are associated or created with that transversal are that yellow one and that yellow one. Okay? Now if I remove the picture, okay, and maybe I need to extend it depending on how you feel about this, I extend those lines so it looks like that generic, I always try to get something back to a generic picture like that, right? Okay? And if I get that, what types of angles are these 2 yellow angles corresponding? What was the relationship that we had between corresponding angles? They're equal. Okay? So we're going to take 3x minus 13 and x plus 41. We'll set those equal to each other. 3x minus 13 equals x plus 41. Okay? Go through and solve then 4x. Once you know what x is, so we get 2x equals, what is that, 54? X has to be 27, right? Okay. What they ask you to do then, and then they just, I think Math Excel is kind of weird in how they did this. They don't, call this angle A and this angle B or anything like that. They say, what is the angle measurement that is represented by this expression? And they have like 3x minus 3 in parentheses, 3x minus 13 in parentheses, and then they got the box that they want your answer. Okay. So when I know x is 27, well, 3 times 27, what's that? 1, carry the 2, is that 81? Yeah, 81. So 81 minus 13, what's 81 minus 13? 68, right? Okay. So I get 68 for that angle. Okay. Now, what is 27 plus 41? 68. The fact that when we plugged things back in and those things came out equal, does that tell us everything that we did was right? Yeah. We started with a kind of the intuition that those angles should be equal. We go through the algebra, we plug back in, and we verify that initial thought that they should be equal. Okay. Let's say I got x to be 20. I do my work. X is 20. I plug back in. 60 minus 13 gives me 47. Plug 20 in here, I get 61. Is 47 equal 61? No. So that tells me the algebra that I did was incorrect, right? Okay. So when you plug stuff back in and try to verify the initial relationships, obviously your initial relationships, your geometry has to be true. But by plugging things back in and checking to see, do I get 68 and 68? If so, I know all my algebra is right. If I get 47 and 61, I know somewhere in my algebra I've made a mistake. Does that make sense? Okay. And a lot of people, what they do when they recognize that they've made a mistake is they just scribble everything out and they want to start from scratch. They want to do that. Okay? Don't do that. Okay? Analyze the work again. Go through it, because a lot of times it's a simple mistake of maybe adding 41 to both sides. Or maybe they subtracted 13 from both sides. Does that make sense? Okay? It's a very, very small mistake, usually dealing with simple addition or maybe transposing signs or something like that. Okay? Where it should be a minus and you put plus. So don't erase everything right away. Analyze your work. Go back through it. Okay? Paying attention to detail. And you can probably save yourself a little bit in regards to that if you don't just scrap it and start from scratch. Okay? And you waste a little time doing that. Also, let's say you go through it and this has happened, so I might as well talk about it. If you're going through a problem and you can't do it 3, 4, 5 times, okay? And you come to me and ask for help. Don't come to me without any work. Make sense? Because when you come to me and you ask me how to do this, we start from scratch. Okay? But it might be you doing everything 100% right, but every time you you're supposed to subtract 41, maybe you add 41 every single time. And that's something that we can clear up real quick. I mean, real easy. And it makes you feel better about yourself. Oh, that's the only thing I was making a mistake on. I understand what's going on. I'm just not getting the right answer because of that mistake. And that's what happens a lot of times. And not so much when people come and ask questions. It's not so much that we don't understand the geometry. It's that we're not confident in our algebra skills. Okay? And we're not able to address those the best way. I want to do that one as well. I think it was 17. Okay, but I want to do a different one because I've already got this in a video online, so I want to do a different one with some different values. So see if we can. Really not changing much. All right. All right, so here's another situation where in geometry throughout the rest of the year, don't force yourself to try to find a particular variable right away. A lot of people try to do it alphabetically, they say, and I think this one you probably can, but they say, I'm going to try to find V first. This is alphabetical, I'm going to find that one first, and they work through it, maybe they can't find that first, so they get stuck and say, well, I can't do this problem. Okay, I get that all the time. Just because of the variables they use, they're not, what happens here is they create a general problem, and then they just throw in variables. It doesn't really matter what's what. Does that make sense? Okay? So don't try to focus yourself and force yourself to find a particular variable first. What you need to do is start kind of decomposing the picture and see if you can make any comparisons, any relationships that you know to be true. So we're dealing with parallel lines here. So the best thing to do is just grab a pair of parallel lines. Okay? So I'm going to grab that pair and that pair. Okay? If you watch the videos from the other classes, we start at the top, so it shouldn't really matter. Okay? Then we'll pick a transversal for those two pairs of lines. Okay? Hopefully you realize that there are a lot of different transversals. That could be a transversal. That could be a transversal. That could be a transversal. And that's a transversal. Does that kind of make sense? Okay? Now, as you write these and you come up with them, you know, they might be useful, some of them might not be useful. Okay? But if you ever write an equation down that you know to be true, write it down, keep it. If you can't solve it right away, don't erase it, because you can come back later and figure something out. So in this one here, I look at that. I know that angle right there. What could you call that angle? What would be an expression that we could write for that angle? Using what we talked about in chapter 1. Is that angle x plus y? Does that kind of make sense? Okay. Is this angle here 20 plus v? Okay. So I'm going to take this picture out. Okay. And by highlighting things, hopefully it has helped us. Oh. By highlighting things, drawing our attention just to that image allows us to get rid of all those other lines up there that were providing distraction. Okay? What do I know about those two green angles now? They should be what's going on?
Okay.
Supplementary, right? The same side interior. So I'm going to set x plus y plus 20 plus v equals 180. Okay? Now, I did this one on purpose to show you that when you write an equation, we know that's true, right? But is that kind of a cruddy equation because of all the variables in it? Yeah, okay? But don't erase it, because what's going to happen is that we might be able to go through the next couple steps and find x real fast, find y real fast. If I can find x and y with that equation, can I plug things in and find v real fast? Yeah. So once you write equal throughout the entire year, and this is all mathematics, once you write an equation that you know 100% is true, keep it. Don't erase it. Okay? Even though you can't solve it right away, it could serve useful later on. I think maybe if we look at this one, and really what's happened throughout the day, and you guys should maybe verify this, is that we get x, y, and v, but we can't find w, or we get w, v, and y, but we can't find x. It's usually people get 3/4 of this problem kind of completed. But I'm going to look at that transversal. Okay? And when I look at that transversal, I kind of see like the letter N, don't you? Okay? with those blue lines. And whether I see I just see the letter N, or I see, if it's flipped, I see the letter Z, okay? But that angle right there, and that angle right there, which are kind of the corners of your letter N, okay? Those are what types of angles to one another? Yeah, they're alternate interior. If I take that picture out, those are the alternate interior angles that we always talk about. And right now, in one of those, we got 42, and the other one, we got a V. So what do you know about those two things if they're alternate interior? They're equal. So we got V to be 42. So now, kind of looking at that green equation, we have something that we could use to make that equation a little bit better. Still a crappy equation, but maybe if I find X next, or Y next, we could end up finding what the other missing variable is. Okay? What if I look at that transversal? I think for this problem, the most useful transversals are these ones going across the interior of this parallelogram. So let's look maybe at that one. Okay, so I see, I'm visualizing, I'm seeing kind of that shape, right? Kind of like a reflected in. But do you see those two angles there? Which would be that one and that one. So X ends up being 85. Okay. So now, if I know X was 85, I don't know Y yet, I know that's 20, and V was 42, going back up to my original equation, now I have an equation that I can solve for Y, right? And that might be an approach that you could use. I don't think it's the best approach, okay? Because I think you can do this. Let's see here. You know V is 42, right? I guess it's the same concept. Look at those parallel lines and that transversal, okay? You know that angle right there because V was 42, you know that angle is 62, right? Okay. That angle there, okay, should be 85 plus Y, right? So you got 62 plus 85 plus Y should equal what? 180. Those are same side interior angles. Is that the exact same thing you would have gotten if you would have combined those two numbers right away? Yeah, there's where that 62 comes from. Okay. So there's different approaches. We could do this problem. Every class period today we've started with something different and still got to the same X, Y, V, and W values. Okay. So you can start from different approaches and honing on those variables in different manner than what your neighbor does. And they might do it different than what their neighbor does and that kind of stuff. Does that make sense? In class, that's what I think the one nice thing about geometry and just mathematics in general is that. Okay. Let's go to the trapezoid question. Somebody had something about that. I think that's 18. And you're starting to see kind of foreshadowing where this stuff is going to take us in other chapters, because there is an entire chapter dedicated to this shape right here. Okay, what is that shape in general? That's a parallelogram. Okay, so there's an entire chapter dedicated just to learning and understanding parallelograms. Okay, so we have to understand and use our logic that we understand about parallel lines to gain new information about parallelograms. There's an entire chapter dedicated to that guy. What's that? That's a trapezoid. Okay, and going back to where was it? The triangle one. I don't know if I still have it. I passed it. Okay, the triangle one. Okay, there's multiple chapters dedicated to that thing. Okay, and the parallel lines and stuff that we get associated with triangles. And really the idea is if we can learn a lot about triangles, this parallelogram is made up of a bunch of triangles, right? Okay, is this trapezoid made up of a bunch of triangles? All right, so if we can learn a lot about triangles, and this happens in chapter 4, then we have a good foundation for talking about all these other shapes. But we still need to know stuff about parallel lines. So if I look at this set of parallel lines, I know that that line and that line are things I want to focus on. Okay, so I have options here. We've got transversals, right? There's 2 transversals. I'm just going to focus on that one. Okay, what could you argue? What would you tell me about those 2 angles right there? Right? They're supplementary. Those are same side interior angles. So we're going to say 4x minus 16 equals 180. Okay? And now allow me to solve for x. And then we want to solve for y. So I transition things and I look at that transversal. And we get the fact that 2y plus then y plus 12 should also equal 180, right? Okay. I think some people start looking at a problem right away, and before they do anything, they see if there's multiple variables in there, and they instantly think back to systems equations and how hard they were, and then I can't do that problem because well, there's x and y's in the whole picture. If I break things down, there's basically 2 problems inside of one here, break it down, and I got a bunch of 2-step, 3-step equations with single variables. Okay. I want to